Today we're going to be doing something a little bit different. We're going to be talking about physics. The main equation we're going to be using today is that force F in units of newtons is equal to mass times acceleration. So mass is in kilograms and acceleration is in meters per second squared. Now what this formula means is that if we apply some force to an object with some mass, it's going to result in an acceleration. So we'll do a quick example here. If we have this box, we'll say the box weighs 10 kilograms, and it's on this frictionless floor here, so there's no friction, nothing slowing it down, and we apply a force of, we'll say, 20 newtons, how fast is this box going to accelerate? How fast will the box's speed change? So we can do this by drawing a free body diagram for the box. So we can draw our box here, and we want to think about what all the different forces on the box is. So we have gravity pulling the box down, but we also have normal force, which pushes the box up. Now, normal force is the force that keeps the box from falling through the ground. So it's the ground pushing back up. And this is going to be equal to gravity. We also have this force of 20 newtons in the x direction. So now using this equation that we have up here, force is equal to mass times acceleration, we can solve for our acceleration. The beautiful thing about this is that it works in the x and y direction separately. So if we add up, that's what this sum notation means here, the sum of all the forces in the y is equal to mass times the acceleration in the y. And so if we look at what our forces in the y are, we have a positive, we'll say up is positive, and to the right is positive. We have a positive normal force, and we have a negative force of gravity is equal to mass times the acceleration in the y. Now, because these are the same, if you take, or we can replace Fn with Fg, and you just get Fg minus Fg is equal to may, or 0 is equal to may, which we can clearly see the acceleration in the y is 0 meters per second squared. We already knew that. The box isn't going to fling into the air and it's not going to fall through the floor. What we're really looking for is what the acceleration is in the x direction. So the sum of all the forces in the x is equal to mass times the acceleration in the x. Now we only have one force in the x. It's 20 newtons in the positive direction. Remember, we said that right is positive. So we got 20 newtons is equal to mass, which we said was a 10 kilogram box, times the acceleration in the x. If we divide both sides by the mass, so 10, we're left with 2 is the acceleration in the x. And we got to remember our units. The acceleration in the x is 2 meters per second squared. So each second, this box is going to be moving 2 meters per second faster. So that's how we use F equals ma to solve for the acceleration of a box.